Press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, apologize. There's some technical problems with this computer. Try to get through this webinar. Hopefully we won't have any more setbacks, but we had something with my network. I'm not sure what quite was going on there. All right. So if you can hear me, please raise your hand. Okay, we're recording this, we always do. All right. What I thought we would do last week, we were surveying people, and we've done a lot of programming there, and we decided to take a little break from coding and to talk about some new technologies, and particularly today, self-driving cars, because it combines really a lot of things we do in the class, electronics, programming, making things in manufacturing. So I hope it's all right, everybody. How many people are interested in what self-driving cars are in the automobile and how that works? Raise your hand. Okay. Well, guess what? It looks like I've got to pitch this to a lot of folks. Oh, we got some. We got half the class, it looks like. So I'm glad. All right, let's go ahead and it's be a nice, a little bit laid back talk tonight. Okay. And then we'll be doing other things as we go down. Now, let's first briefly talk a little bit about the history of the automobile. All right, let me move this over here. All right, no. So, this history of the automobile goes, make sure there's no questions. Good, I'm glad. Got folks who are big car enthusiasts, awesome. All right, history of the automobile. On the left is the very first, what you would even begin to describe an automobile, powered by steam, incredibly slow, and on your right is a new modern Tesla. So I get to the history. It was built by a Frenchman back in 1769, before this country was formed, before our country was formed. And it was incredibly slow. It was not, frankly, not very practical. Horse carriages were still superior technology. By Joseph Cugnot. Jean-Joseph N. Lenoir built the first internal combustion engine, and it was one cylinder. And what you need to understand, and we sometimes forget, the French were some really great engineers in the beginning. They're the first to make hot air balloons. They are, frankly, the ones closest to catching up with the Wright brothers later in aviation. So he builds a gas engine. And there's all these challenges, because remember, with gas engines, they blow up. Gas doesn't burn. That's what everybody says. Gas explodes. So always, don't pour gas on a fire. You get white gas and kerosene and things like that to start a fire. Never use regular gasoline. It blows up. It doesn't burn. Okay? Now, Carl Benz, one of the founders of Mercedes, is the first to build an automobile powered by an internal combustion engine. That's actually like a tricycle, if you can believe that right there. The engine's back here on it. There's a steering wheel, believe it or not. There's kind of the start of a brake, but really engages the engine more. It's very crude. It's in a trike conformation. Formed that way. Gas, not gas. I don't know what the heck is that. Let me see what I did wrong. Someone's pointing something out here. Yep. Gas engine. Yep. All right. Then Daimler, who would later go on to help form Mercedes-Benz, Daimler-Benz, Mercedes. Actually, his first vehicle was a motorcycle. It's this vehicle right here. Look at the wood. I mean, this would have been, and the leather seat on top. But you imagine trying to steer this thing like this, and it's got training wheels. That would have been painful. Now, so his first vehicle actually is a motorcycle. He does come up with the first four-wheel drive vehicle. Again, notice on his motorcycle has that turning arm. He's got a turning arm here. And a lot of this can be that the wealthy would own these things, and they had a driver, so it wasn't them having to turn it. Yeah, oh yeah, bumpity bump is right. No doubt, that would have hurt. You know, and look at bicycles were, you know, it was very hot. Bicycle, we always think of bicycle technology, which was, you can see, incorporated into the early automobiles. The Wright brothers get, like, for example, the Wright brothers are often put down pejoratively as, oh, a couple of bike makers. Well, the reality is, bike was the leading cutting edge technology at the time. So we sometimes judge things by today's standards. So bike technology was the new internet of the age, for example. And not surprisingly, you see some of these things brought into these. You also see carriages, because horseless carriage. When you start new technology, you generally put up what there is in the existing technology and compare it. A little bit of trivia. Let me see if I can find it. Bear with me one second here. I'm going to look something up because it just makes sense to hear. Let me get out of this. All right, hang on bear with me 1 second. Bear with me. Okay. When you go to Harvard, oh, that's not what I want. All right, there's a freshman red book. Let me bring this up here. Let me go ahead and let me put this in this, guys. Duplicate the slide here. Let me add this because I was just thinking as we did this. It'll just take me a second. You see this Harvard book? This is a good thing for you to realize. Technology, we just evolve on technology. That lists all the Harvard freshmen and information about them. And you wrote it down so you would know everybody in your school. And they handed it out. All the folks at Facebook did was take this and automate it fundamentally. So let me just insert a little Facebook slide here so you can see both. So the people that made Facebook just automated that. So just like in those cars, you see the existing technology at the time. And you can see that in autonomous cars coming out. But see how there's a motorcycle right there? Wheels, this looks more like a bicycle. This looks like a carriage. You can almost see right now where the lines went through, a horse would hook up. There's nothing wrong with that. And give people at Facebook and the early car adapters credit. Nobody else thought to take that and put it online. And then once he did it, it was so popular, he realized it could be so much more. So let's give them all, give everybody the credit they deserve here. Any questions on that? So anyways, freshman founder of Facebook, which of course right now his name escapes me. Wow, big shit. All you do is take that and automate. So when you're going to do technology, you can do it. Now, Moving back on over to cars, Daimler Wilhelm Maybach with men's manufacturing firm 226, they joined it, all right, to create the Daimler Benz. Let me put that in, sorry. 1926 to create Daimler Benz. The joint company makes cars today under Mercedes-Benz name plant, but remember they have the Maybach. It's their high-end, their super high-end car. And I just think it's interesting that Mercedes was started back in the middle of late 1800s. Thank you, Mark Zuckerberg. Thank you, Kevin. I'm from this. Now, in the United States, there were a bunch of car companies started out. 1890s, first car that was produced on a large scale was an Oldsmobile. In 1901, Oldsmobile sold 425 cars. By 1905, they went to 5,000. So in 4 years, they were selling 10 times as many, which is a huge jump. The Coach was king of the road. Now it's the Oldsmobile. All right, so that's what we're just talking about. Here it is, Coach, and there's an Oldsmobile car. Now, to go with that, in the early 1900s, the automobile cost thousands of dollars and only the rich could afford it. Just as importantly, the early car manufacturers, if you bought a car, you were expected to have in the back of that car a whole test box of tools. And I'm not just talking about you needed a wrench to pull the tires. They wanted you to take grease. They wanted you to take oil, which, okay, oil, we bring oil sometimes. They wanted you to take valve tools to remove the valve covers. They wanted you to be able to take chain link. They wanted you to be able to take gasket material. So it was much more, maybe the car works, maybe it doesn't. Not surprisingly, cars back then, everybody that owned them for the many times had to be a chauffeur. And so people riding in the car wouldn't be bothered with driving. And there's a certain irony when we talk about autonomous cars that we're moving back towards that people might not be interested in driving just to drive safe. Okay? Yeah, very user unfriendly. But the wealthy, they didn't care. But let me ask you this. How many of you right now are super excited about driving? Can't wait to get your license. Do you realize it's there's less than half of you? No, you're middle school, so that might make up. But what I would point out, people aren't in a rush to get cars like they used to. So again, as cars returning back to this, where we want to be chauffeured around, only the chauffeur this time is now autonomous cars. Now, so far I just covered a lot. Anybody have any questions there? I got more people say yeah. All right. Now, to get the price down, when we make things, we always give a lot of credit for the inventor, as we should. But sometimes it's not the device itself. It's not that simply coming up with a four-wheel car, a motor car, a horseless carriage, as they were called. We got to be able to assemble it. And the money has always been, can you make it so everybody can use it? Because you got a lot more buyers then. Henry Ford comes up with the assembly line. Up until that time, for the most part, cars were made by a couple of artisans working on the car from beginning to go. They might automate and hand off stuff, but it wasn't super organized. Ford is the one to come up with that. He also was innovative in paying $5 a day king's ransom, and people were criticizing him. How can you pay $5 a day? Well, what he recognized, if I paid $5 a day, people could buy these cars. There'd be more people buying the cars. Also, early on, Ford was selling trucks and things because he knew farmers. We were still very agrarian then. We were moving into the factories, but agrarian. You live in a farm, you got to be able to fix yourself. And Ford knew that if you could make it cheap enough and simple enough, that a lot more people could buy it. And it wouldn't be so hard to maintain. People would be used to it. I mean, he did things like when people send him parts, say the Ford factory was buying tires, the wheels for the tires. He would specify the box that the wheels had to come from and the quality of the box that shipped the tires in. Because when the wheels arrived, and I'm not sure it was wheels, but it was other parts, you're going to get the drift of this, they would tear apart the box and reuse the wood in the floorboards of the car. So they didn't waste anything. And he was famous for saying, you can have any color you want as long as it's black. Why? It's expensive to change the colors out in the car. Hey, just get it black, you're fine. He did all that to drive down the price of it. All right? Luke here says it's his favorite person for it. So an amazing guy. Didn't really like hanging out with the elites. He was a farm boy through and through, I suppose. Then, manufacturing, epitome of that is the Model T Ford. In a country, at that point, I'll have to go back and look. That's a great question here. Can someone real quick check me? How many people were living in the United States by the 1920s? 1920 census, how many? Has anybody got a number for me? 1920, 1930 census. Can you guys look that up for me real quick? $106 million. Thank you very much, Liam. 15 million cars Ford sold. That's 1 out of every 10 people, roughly. That's an incredible figure. That's complete domination of an automobile market. So, really had a great idea there. Now, on another note on this, people always think electric cars are the newest thing. When in reality, my grandfather used to point out to me when he was alive, and he passed away back in 2004, and he was 96 years old. So he saw this. His dad had a early gas station automobile repair business, and their big first thing they did was come up with free air. That was the deal. You had to pay for it up to then. All right. Now, but in reality, they made more gas, steam, and electric cars than they did gasoline. And there's the batteries, right? And there's the motor and everything before. There's a gentleman and a electric car. I think that could be Ford. I don't know that for a fact. And today we think of electric cars, we think Tesla, modern, very capable car that's coming out right now. The thing is, the irony of this is, when we get back to this assembly line, is Tesla's come up with a great product, but they're having a heck of a time manufacturing the car. They have not gone anywhere close to what he wanted to make a family affordable car. They have the 75,000. They know you've got to be able to build and buy them. All right. Any question on that in the history? Oh yeah, they're struggling big time. The problem they're running into, and this is where the other car manufacturers are probably saying, told you so, is they just bottlenecks. Like they have a bottleneck in the factory. They're having to make some pieces by hand. Well, we already just said you can't sell cars today making them all by hand. You've got to be able to make custom pieces. You've got to be able to sell them quickly. So, it's good warning to other Silicon Valley startups that, hey, maybe somebody's been doing something for 100 years, knows a little bit about manufacturing, and it's not necessarily it's going to be easy as you hope. Now, I hope it works out. I like Tesla and electric cars. And I think you're going to see Tesla electric cars where everything's headed for simply the fact that now China, India, and California have all made big, huge commitments to electric cars. China's goals by 2040 in your lifetime, maybe mine, but certainly in yours, to have electric cars as the primary vehicle for driving around. And that is going to be huge. So I had a gentleman come speak to my school. He was hired on early on as Google, worked on Google Maps, then SpaceX with Elon Musk, and then later with Zipline. He's there now. And he felt very confident that electric cars, fossil fuel powered cars, are on their way out, according to everything they've been dealing with. Thank you for catching that, T. Tess reintroduces. Thank you. All right, let me see. Luke says, their tech is futuristic, but lagging as good as it could be. Great, and there's a little software. It's still self-driving, autonomous cars have still got work. But again, let's give Tesla and everybody else trying to jump in on this. They've gone from 0 people doing this stuff. GM had an electric car, which they killed. They've got the Volt now, but American consumers haven't been super crazy about electric cars. We love our big SUVs. And we're worried about range. Though honestly, the range thing, minor cars are getting over 200 miles a day. Do a check next time. See how many miles your family's driving every day. Rarely do you drive 200 miles. And since most people have more than one car, the argument goes, fine, take the other car when you really want to go farther than that. Those with new charging stations creeping up, I think that'll change. The issue with electric cars is going to be the same issue everywhere. Which comes first, the car or the charging station? Can you agree on what the standard is going to be on a charging station? So those are all challenges to electric cars, but they're not unsurmountable. It's just a question of will. All right. Any other questions there? All right. Now, when we talk about autonomous anything, this is HSI, I forget. I want to make sure I give them credit. LHI, I'll post it later where we got this from. But this came out of Google. When they talk about autonomous, so this is developed by Google. Obviously, Google immediately, talks software. They're a software company first, hardware last. So, they develop robotics, drones, machine vision, AI neural network, all the software for those kinds of things. And then in terms of for developing to get started, then you need technology when you're actually using them. So that's location technology, self-driving car maps, wireless updates, cybersecurity. Those are all the issues. This is development phase. This is the operational phase. So you really have some different challenges at each phase of this. Okay? But as you can see by this thing is really taking off. So, pardon me. Area 1, we have fully autonomous vehicles being developed for consumers. They're already a reality in industrial fleets. Car manufacturers begin to access strategic impact. You're going to have new models of what people are doing. Like, If we had a fleet of autonomous cars, folks, and they're out driving around, and you know there's a fleet, you know you won't have to wait, and you could go on your phone like an Uber and say, someone pick me up. I want to go cross town. Car comes up, you wait 10 minutes, jump in the car, it drives over, drops you off, you're on your way. Will we all really want our own cars? Will we need as many? Maybe we all keep one, but right now it's more than 2 cars per person in this country. To me, that would be amazing. Maybe people your age go, I don't need to drive. I can autonomous. I can go wherever I want. Why do I need to care if I drive? I don't want the expensive owning car. Yeah. Right now, Luke is saying 200 miles. Yeah. Tokyo, Luke is telling me on both that it's already happening in Tokyo, that you have cars that ride around doing that. In fact, Luke, if you want to tell us, instead of me saying, let me see. I'm going to put you on, Luke, okay? Luke? Luke, can I hear you? Can you hear me?
Yes.
Okay,
Can
what
you
were you
hear
going to say
me?
about Tokyo, man?
They have like four-person cars that like are on a schedule and stuff, and if you ask to pick them up, if you can ask and they can pick you up and drive you around. It's
Yep.
it's crazy.
Yep. And see, what's great about, I'm going to mute you there, Luke. And see, what's great about that then is we don't need as many parking spaces. Think about it. There's all these unintended consequences. Air probably would be cleaner. Traffic could be better. Maybe not. You're still going to need to be able to move people around. I'm not convinced on the traffic. There's people arguing the traffic will improve. I'm going to buy that. Okay. I will tell you right now, trucks are coming. We're going to watch a little video in a little bit about trucks and this AV equipment, because that is really, not today, next Wednesday, but trucks are a big deal in this. All right. And enough so that people that drive trucks, won't get to trucks. All right. The after-sales service is reshaped. Churros will shift from covering individuals to covering technical failures. In other words, if it's an electric car, that after service, not as many of us driving on a single car, well then, what does that mean? And then, the next one, oh, sorry, I get the yawns. I can't get out of it. I apologize. It's very rude. And I apologize. I think the time change is still catching up with me. But anyways, insurers shift from covering individuals to covering the technical failures. In other words, you'll always be, we're all going to be insured for us. But what the big money for insurance companies will be going to GM or Mercedes-Benz and ensuring that their self-driving car doesn't have some kind of problem. But the number of fatalities could go down. I've seen as anywhere from, I've seen them say from 30% to 90% cut in the number of crashes. And it is pretty impressive. So insurance companies say, well, we're not hitting each other as much. Where are we going to make our money? Well, we're going to make our money by making sure that General Motors, Mercedes, or you name the car manufacturer, has got insurance for when their systems fail. And folks, systems fail until we use them long. But, you just got to figure out, well, what's your rate of failure? We'll get into this down the road. But right now, on a given day, there's 65,000 aircraft in the sky. Big airliners, 65,000. We get a crash every 2 billion miles. The odds of you being in an airplane crash are much more dangerous driving to the airport than getting in the airplane. Well, just think with this, we start automating these cars, we learn from what we're doing, we can drastically reduce. Will we get rid of all wrecks? Absolutely not. But we're not trying to get rid of all wrecks. Supply chains, logistics, not something we're really covering in here very much, are going to change. All right. But after 2030, which, is only 13 years from now, that's kind of wild to me. Free up, because you're not having a drive. You got 50 minutes a day. Just relax. I mean, you can be driving, but you can be reading, kind of thing. This is the big thing they're arguing: parking space by billions of square meters. Well, yeah, maybe. But people are still going to be more people by 2030. And even so, even if the self-driving car, instead of people each having their own car, we're using self-driving cars and we're automating in the city, and it's 3 people to 1 car, you're still going to have a growth in population. I think parking will still be a big problem, as so will traffic. But at least you won't be going crazy. Now, this says 90% savings in crashes. I think it could help you all. I think young drivers generally are responsible for a lot of the wrecks. And with a self-driving car, it may prevent you from doing something dumb. All right, but everybody's dumb when they're in high school. All right. Also, a side benefit, once you have self-driving cars, you're more likely to go with robots. They're not going to find it creepy. I've said this to y'all before. I'll say it again. If your dog could talk, carry conversation with you, wouldn't you treat him differently? Or her differently? Now imagine if your computer could talk. Not Alexa's talk, like it's obviously a robot. But down the road, we get it well enough. My argument would be, we'll treat them differently. All right. Now, in the next few minutes, let's just go over that. When we talk about autonomous driving cars, what are we really saying? Well, actuation, that's actually steering, braking, acceleration, controlling all these things. All right? So you got to be able to do that. That's one part of your system. That would be more of a mechanical engineer right there. Mechatronics is going to control it. All software is going to control it, so you need this. They have this RoboCAD that can respond to you and stuff, but can't walk yet. Give it time. All right? So first thing, if you're the engineer and I'm sitting down, we got to think about, we're going to make a self-driving car. What do we need to think about? Well, first thing you got to think about is braking, steering, and acceleration. Honestly, that you can learn to control. That's not a big push. All right? Cloud, that's what you're going to need to get a couple things. You need, first of all, really good mapping. You need real-time updates. Has that road changed? Does your system understand what to do when the road changes? We don't need our self-driving cars coming up to a barricade and just sitting there and doing nothing else. That would be very frustrating. So the way to do that, and using cloud computing, is you can have the cars constantly learning, taking in data, and handling it. Now, we'll talk later about the negative of that. Well, not today, tomorrow. All right, or Wednesday. All right. Perceive an option. This is where right now robotic vision is really popular right now. Carnegie Mellon, if you come out of the Carnegie Mellon with a specialty in computer vision for the next few years, by the time you get to college, I think this will change. It's a $200,000 a year job right out of college, living in Pittsburgh, which is not an expensive place to live. All right. Drive control. All right. Converting algorithms, that's software code, into drive signals for the actuators. The actuators are the steering, braking, accelerator. So this is a software that converts your numbers, zeros to ones, to actually turning the wheels. All right. Another big item in all this is decision making. This is going to be one of the hardest things for it to do. We humans understand, that's a groundhog or a baby carriage. I'm sorry, Mr. Groundhog. Hopefully I can avoid Mr. Groundhog, but I'm not going to go off and get killed avoiding Mr. Groundhog, and I'm certainly not going to run into a baby carriage at Mr. Groundhog. A computer has a heck of a hard time with that decision. Also, the thing they're really trying to figure out, what might frustrate you as you have a self-driving car, is the decision making. You can do that. You can turn right a bunch of traffic. Is our self-driving cars going to be so cautious that leaving on a right turn is going to be very frustrating? That's one thing we're just starting to try to get our head around. Okay? Not surprising. Again, we use that cloud method for great maps, but you got to localize and map it. So we're constantly wanting to know. Now, one thing that will probably happen over the next 30 years is all cars will have to share a certain kind of data. So all the cars are constantly talking to each other exactly where everybody is on the road. All right. Now, another part, and this is a team of people work on this, is analytics. You're bringing in lots and lots of data to see where do customers make a mistake. Where does our self-driving car fall down? And I guarantee you, they're not all working perfect yet. But analytics, by monitoring everything going on in that car, recording all that data, putting all that data through, getting rid of what's called white noise data that isn't important. That's what they call white noise. We get so much information come in. What's the important information? Because most of it's not. We're writing great analytics to do that is really a good idea. The operating system. Cars have much more software lines of code than Windows did when it came out. A lot more. I can go back and look up. There's a amount of computer code in a car. I'll pull that up later. All right. Now, computer hardware. We all know there's a lot of computers now in your computer car. We're there. That's a lower thing because honestly, we have 40 years of experience with computers. That's not a big get in the way, especially with the Silicon Valley people all excited. Now the next one is sensors, multiple sensors including LiDAR, sonar, radar, and cameras. We almost could say you can't have too many sensors on the car for this. Any question about that? Now, not surprisingly, in the last 2016, in terms of units, millions of units, we've seen this big, incredibly demand for advanced driver assistance systems. You'll see companies market it under safety. And that's what they have out there right now. And here's what the demand and here's what the growth has gone. 160% growth, almost across the whole board. Distance, that would be, make sure the car is going to let me run into somebody. If I set the distance on it, I don't have to worry about it anymore. Lane departure, if you start weaving out of a lane. Night vision, so you can see better at dark. We're going to see more of that. And adaptive front lighting system is another thing where it automatically changes on your conditions and what you're trying to do. As the prices comes down, like a lot of new technology, the new stuff goes in the expensive cars. As the price of that comes down, and get distributed across cheaper cars. And we're already seeing that. All right? There's all this is moving in, but just look at the growth here, folks. It's huge. Since 2014 to 2016, a 48% growth of advanced driver systems. Making sure. All right. Any questions on that so far? All right. Next week or Wednesday, you're going to go more into self-driving, and we'll get into really the nuts and bolts of it a little bit more. Now, just so I get a sense, how'd you enjoy this webinar on this? Are you glad we took a change here and did cars? We're at 50%. If we could go ahead and vote. About half is voting, folks. Let's get there. Okay. I just have one person I think I'm disappointing here. I really would like them to let me know. I'll go back and, all right. We got 7%. Can we get some more voting, please? I am really curious why you found it poor. So I don't, didn't like the topic, something I did, or what's going on. Most everybody else seems fairly happy. Come on, we're at 7%. Can we get up to 80, and then we can close this up? It's still 70, but I'm going to stop this in the next little bit. 5, 4, 3, 2, 1. I'm going to close the poll, share results. Most people, all right. Now, the next thing is just remember, 7th, 5th, and 7th and 8th graders, you have lab Thursday night and Saturday. You have lab this Thursday and Saturday. Okay? Again, so apologize for a little bit of a click. So far, everything seems to be running fine here. I'll talk to you all later. Okay? Thanks. Bye-bye, everybody.